Welcome to the LRC, because Google was too boring. You ever wonder why eating that pizza you left outside for a week gave you the worst stomachache? Does eating random food you left outside for a week always give you a stomachache? As silly as it sounds, it's a valid question. How do we know why eating moldy, disgusting pizza from 3 years ago makes you sick? How do you know anything at all? Scientists have the secret strategy they apply to every question they need answered. They call it the scientific method. It's a very creative name. Let's get into it. Our first step is observation. We all have eyes, right? When you look around, we can use our eyes, obviously. We can see that the sky is blue or the cookie jar is empty. But when we observe our surroundings, we also have to use our thinking caps. We can observe that the cookie jar wasn't empty yesterday, or that the sky turns black at night. After we see everything around us, we come up with a question. We could ask why the sky is blue now, or why it changes color. What other colors could it be? Or alternatively, we could ask why the cookie jar is empty when it had 2,000 cookies crammed inside yesterday. It's a very big cookie jar. When scientists like you want to find something out, they may not have the answer, but they can make a guess based on the information they already have. For example, we may suspect your friend Bob of eating cookies because he very discreetly takes a cookie every time he sees you. This guess is called our hypothesis. It's simple, but it's smart. Just like the random guesses you make in a test, it uses existing information to make a prediction. These hypotheses use a specific format, the if-then format. If your friend is in a room full of cookies, then he will eat all of the cookies. Now for the fun part, we conduct the experiments. Kinda, not yet. Experiments are how we learn or find out if our guess is correct. When we conduct experiments, we test to see how certain things in a situation are affected by other things. These things that affect and can be affected are called our variables. We have three kinds: the dependent variable, the independent variable, and the constant variable, which is kind of counterintuitive. It's also just called a constant. Our dependent variable is what we observe in the experiment and or what we check to see if the experiment is successful. In this situation, it's the amount of cookies we have in the cookie jar. Since we want to see if our friend eats the cookies, we look to see how many cookies there are after Bob stops by. Speaking of, Bob is our independent variable. When he's in a room with cookies, we expect him to affect how many there are by eating them. Independent variables are the if part of the hypothesis, the one that would affect your dependent variable. Finally, the constant is what doesn't change in the situation. So in this experiment, it would be our cookie jar and the kind of cookies we use. It's very important that we don't change these because they have to stay consistent to ensure that our experiment is accurate. Okay, so what actually is the experiment? Well, if our hypothesis is that Bob keeps eating our cookies, we need to test that, right? First, we can go eat lunch with three friends: Magnus, Zoran, and Lee. We call this our control group. It's a group where Bob, the independent variable, is not present. We bring 10 cookies with us to lunch, but we don't give them any. Afterwards, we count how many cookies we have left. The next day, we can eat with Magnus, Zoran, Lee, and Bob. This is our experimental group. It's the one the experiment is actually about. We bring 10 cookies today as well, and we compare to see how many we have at the end of each lunch. If we have less cookies in the time we eat lunch with Bob, Bob is probably the cookie stealer. Finally, our conclusion. Were we right or were we wrong? Did our friend really eat our cookies? We can see whether he did through data collection. The data for us to analyze in this case would just be how many cookies were left after, through which we can see that Bob is a cookie thief. Now that we've proven our hypothesis, we need to have our conclusion. We need to understand what this really means. Since Bob has been stealing our cookies every day, we can conclude that we need to hide our cookies from Bob And he owes us approximately 1 billion cookies. So, what did we learn today? Whether we're looking for missing cookies or the cure to cancer, we can apply the scientific method to everything. It gives us a convenient way to sort out everything we know, everything we don't know, and everything we want to know. In summary, the scientific method is the smart way of asking why, with 6 steps. There's observing the world around us, questioning our observation, forming a hypothesis to answer our question, conducting an experiment, analyzing the results, and then forming our conclusion. So, with all this in mind, why don't you go put on your thinking cap yourself and question the world around you, specifically the Bobs in your life? Question them, please. Your cookies deserve better, man. Come on, just